So the point here is causation does not, typically, we don't have big change occurring instantaneously in the state of the system. That's another way to put it. We don't have the stocks instantly changing. We can't instantly change our level of addiction to coffee. We can't instantly change a heroinist's level of addiction to heroin. We can't instantly change the number of people with the disease. What we can do is we can lower the number of people getting it, increase the rate at which they're treated, and the disease is cured. We can't instantly change things. Stocks change by changes to the flows, and it takes a while for them to affect the flows. Okay, and typically all causal loops in a diagram need to involve some stock. That's what leads to some delay in the process as it feeds back to itself. That is what is changed by that flow, and that then affects other things. So, here we have population, we have some bursts, and this is part of the loop. Here's the stock, here's the flow. Okay, so those are some comments on stocks and flows. Now, I had some nice. I thought I had a little here. Okay. Here we go. So, here are some things. Help me understand if these are stocks or flows. Sorry? Account balance is a stock. There's some current. Okay, income? That's a flow. That's a flow. We could have a giant change to our income, but it'll take a few years before it starts to hugely impact our net worth. Yeah.
And the account balance, what was the first one?
Account balance?
Account balance, will it change it significantly? I mean, for example, now there's some money
Yes.
in the bank,
Yes.
and we take out all of it,
Okay.
so we could instantly change the amount.
Okay. So this is a good comment, and it's an example that I feel a little bit awkward about. So the fact is that you're withdrawing that money through a flow. If you take your account balance, what are the flows into an account balance? So here's your So you have some coming in through income, and then there is spending. Yeah, spending, and maybe you have some other deposits, or other investments related gains or what have you. You have some spending, and you and other withdrawals, right? You just shift it to currency or whatever. It's a withdrawal.
Share is less in a share, we can say this.
Yeah. I'm not totally. The truth is, yes, you could take out with the withdrawal instantly all the amount in the account in a way that we don't have the luxury of doing with the CO2 in the atmosphere. In a way that we don't have the luxury of doing typically with water in a reservoir or with oil in the ground or what have you. There is a state of the system. Here we have a little bit more leeway over it in terms of the
This situation is
there's less in it. Yeah.
Situations like this.
That's right.
Yeah.
If it's for Bill Gates, it's not the same.
that's
There's
that-
a maximum amount of
that's right. Unless they mint a Bill Gates coin where he's on the front and it costs $64 billion or something. People noted when the value of the bank account exceeded what could be represented on a normal 32-bit computer at the time. So yeah, it's different there, and you have typically smaller amounts coming up. But you're right, with a small bank account, you could sort of withdraw that. So it's not a great analogy. But I think you can reasonably call this a stock. There's just less inertia associated with it because of the
the
amounts.
flow is a comparable size to the stock.
Correct. Well, okay.
But I mean,
Okay.
you would assume that that's the case. If you're dealing with like a bathtub size of water,
Yeah.
and you've got a big bucket, it's going to be less stable than if you have a pool and you have a bucket. And that your bucket is the only input and output from that.
Right, okay, yeah.
So that stability,
Okay.
inertia that you described, is probably a relationship between the time,
Yeah.
the time unit of your model,
That's right.
and the flow versus the stock, the relative sizes compared to integrate the flow over one time unit.
Right, okay.
The percentage of that of the stock is.
Okay, I like what you're saying, but you said something early that you later qualified in a nice way.
By saying the word integrate.
Yes,
Yeah.
yes, you nailed it there. But I was just going to say we have to be cautious. This is a common thing people jump to. Okay, suppose we have a value of a stock. Okay, that maybe this is measured in people, and then I have a flow. What is flow measured in? If we have a stock of people and there's a flow out of it, people per unit time, yeah. So people per some unit of time. Okay, cool. Some unit time. Now, can we? So suppose we have 100 people, and we'll call this value the flow of F, whatever it is. Okay. Can we legitimately say is F greater than P? No, we can't. Why not? Because they're different units. It's kind of like asking, is meter bigger than a square meter, or bigger than a square centimeter? Well, it's a different sort of thing. You can't say a meter bigger than a square centimeter in a legitimate sense. You can't compare an area with a length. And something you can't say is a liter larger than a centimeter. What do you mean? Is a second bigger than a meter? No. It doesn't make sense. It's sort of a category argument. So you can't really directly compare stock and flow, and you can't subtract them. You can't talk about P minus F. If you want to discount what's going out, what do you have to do? You have to, over some period of time. You could do that by multiplying it by some delta t, or you could integrate that up. In other words, you could take an integral dt of f of t over time. But the point is, you got to be careful about saying, is the stock bigger than the flow? Really, we're talking about sort of bigger for a given unit of time. You have to consider that. Okay, so that's good. So do remember that if we have a stock and a flow between them, this stock diabetic has this flow into ESOD patients. Those two stocks have to have the same dimensions and units as each other, and the flow between has to be that dimension over t, over some time. So we have people who have diabetes, people who have end-stage renal disease, and then we have some number of people per, say, month or per day or per year, however you want to quantify it, whatever the time unit is, that are diabetics that develop end-stage renal disease, right? Okay, so a little bit of a diversion there. So let's continue on sort of our discussion here. So I don't know how many people here have heard the term prevalence of a disease before. Okay, so that means sort of how much of the disease is there in the population. So say we could talk about prevalent count. So how many people have that disease? Is that a stock or a flow? Okay, so stock. Incidence refers to how many people are getting it per year, per day, per week. What is that? It's a flow. Yeah. Okay, we could talk about current temperature of this room. It's a stock. And we could talk about births. Flow, okay, flow into a system. Profits, flow. The one thing that may help you is if you take profits. If I say, is your company a big profits? And you say yes. And I ask, what are they? And you say 100. Well, or even if you say 100,000, I say, well, per day, per year, per month, it matters a lot, right? Per millisecond. Um, so that's a sign of a flow. It's some amount per some unit of time. So that smells like a flow. Then if you've got a burst, similarly, if we said Saskatoon is a growing city, we say we have 100 bursts. Well, okay, per what? Per day? Wow, that's grown. Man, you're growing. Per century? Yeah, no. Okay, you're not growing too fast. How about interest coming into a bank account or investment income? Flow. Principal? Stock, yeah. Shipments? Flow. Inventory, out of which that's a stock. We have some amount of widgets in inventory. When they get ordered, we ship them out. So we're doing well. We have 1,000 shipments. Well, 1,000 per what, right? Could you say we have 1,000 items in our inventory? Yeah. 1,000 things in our inventory right now. Yes, Kurt.
I'm noting a potential issue that's going to come in
Yes.
to
Yes.
the position speed.
Okay. Yeah. You got it. Yeah, the physicists always think this way, and they're quite right. And okay, so you may have caught my hedging there earlier. When we say something is, I said it smells like a flow if it's what? If it's per unit time. You can't measure it instantaneously. A flow, if we had to ask, how fast is the South Saskatchewan River flowing? One way to do it is to, if we ask, how fast, so I put a couple of years ago, I pounded a well in my sand well, and we started to pump water out of it. And the question was, how much water are we getting out? How quickly is the water coming out? How do you do that? How can you do that?
Volume change, the speed of water.
Okay, so tell me in mechanical terms, what would I do? So if I had a bucket,
How long
how long
it takes for
it take to fill a bucket? So maybe it takes a minute to fill a 10-liter bucket or something like that. It could tell me, like a 10 liter per minute out, right? So that's pretty useful. That bucket is the water in that bucket is a stock. I'm measuring the value of the flow by seeing how long it takes to fill up this stock to a certain level, right? Often, it's hard to measure flows instantly. How quickly the South Saskatchewan River is flowing at different times of year. How quickly water is coming out of something. How quickly, how much current is flowing over things. Often we can more easily accumulate some amount. In other words, get a stock that fills up with it, and then ask over what time was that measured, and get the value of the flow in terms of amount per unit time. So, Kurt asked a question. So let me just